we are using the one adapter, right? Adapter. So what are the components are present in that adapter? Did you see any damaged adapters of the mobile phones or TVs or laptops or any other devices? Did you find any damaged adapters? Okay. So, okay. See the applications of our electronics. So we are using the TVs, computers, and solar, not in solar systems means to in the batteries. Okay, to convert the AC to DC. In that case, we are using the electronics in the solars. Okay. Now, basically, you can remember. Thank you, sir. You can remember the mobile adapters. There is a small device. Okay. So, tell me some electronic devices names. What you are idea on that? Tell me some electronic devices. I'm asking the not applications, electronic devices. What are the devices are called electronics? That is application. In refrigerators, we are using the uh, electronic devices. Name some electronic devices. Resistors, capacitors are not electronic components. Okay. Do you remember the periodic table? Okay. So in that periodic table, 7 periods are there. So many groups are there. 18 groups, right? So in that, are you remember the fourth group elements? What is the last group elements? What are the name of the last group elements? Noble gases, correct. Why it is called the noble gas? What is the property of the noble gas? In nature. Inert in nature. Okay. So in the noble gas, okay, you can remember the word noble gas and noble in the last group elements. Okay. Now, coming to the fourth group elements, depending on the group number, that atoms are having some valence electrons. Okay, we'll discuss later. Okay. Now, okay, coming to our topic, I think you have the one idea on the what electronics, right? So the electronics or example for the electronics are diodes. I think now for an idea, transistors. Okay, so this basically the basic component for the to manufacture the semiconductors is the fourth group elements. The fourth group elements, tell me some fourth group elements in the periodic table. Carbon, silicon, germanium, right? Now, these are called the semiconductors. Okay. Now, what is the nearest noble gas to the semiconductors? That is the fourth group elements. For example, you can assume the carbon silicon. Silicon is the fourth group element. So what is the nearest noble gas for the silicon? Noble gas. Neon and argon, right? The neon atomic number is 10 and argon atomic number is 18. Okay. So if the any atom is the noble gas, that the noble gas is having the, for example, you can consider neon, that is the 10. So that 10 is electrons are then and protons also 10, right? So we can't break that electrons and neutrons, electrons and photons. Okay, you can remember the word electrons. So we can't break. The noble gas we can't break. Okay, now coming to the silicon, is the atomic number is the 14. That is near to neon and near to argon. Okay, so when that silicon can act as a noble gas, when that acts as a noble gas, the silicon atom. Silicon is a 14 atomic number, and that is having the nearest is the neon, and other one is the argon. Yes, good, good, very good. So if that silicon is having the four excess electrons, okay, so that four excess, if it is accepting the four electrons from the another atom, that will have the number of electrons with the silicon is the 18. Okay, so because of, and if the silicon is donating the four electrons to any other atom, so that is the comes as a 10 electrons, that is a neon noble gas, right? So now because of this property, losing and adding, accepting four electrons from the other atom or for donating the another, that is the four electrons. Okay, so now because of this fourth group elements or acts as a between the insulators and conductors. Now we are entering into the topic, the insulators and conductors. What is insulator? It does not allow the flow of electrons. What is called the flow of electrons? What is flow of electron? The flow of electron is current. So current will not flow. That is in insulators. Tell me the some examples for the insulators. Plastic. Okay. Now, okay, coming to the plastic. If you are increasing the temperature of the plastic, you can take the some fire and you can apply here. We are increasing the wood temperature. Then the wood acts as a conductor. No, that is still in insulator only. But coming to our semiconductors, that is a carbon, silicon, germanium. If you are increasing the temperature, that increases the flow of electrons. That allows the electrons can be increased. So that is the conductivity will increase. If you are decreasing the temperature, then the flow of electrons can be controlled. Okay, that's why we are calling the fourth group elements are the semiconductors. Semi means off. Semi means off conductor. Okay, why it is called the off conductor? Because the temperature increases, that can be act as a conductor. If the temperature decreases, that can act as a insulators. Because of this property, the fourth group elements are called the semiconductors. Okay. But these semiconductors we are using to manufacture the semiconductor devices. Okay. Semiconductor devices. If you are using directly that semiconductor to make a our semiconductor device or diodes and transistors. Okay. The diodes and transistors. So directly, if you are using the semiconductors in the to make the diode and transistor, what will happen? That is the temperature dependent. If the temperature increases, conductor, temperature decreases, insulator. So we are making the diodes and transistors are no use because of the temperature variations. So that's why now the semiconductors are color కూడా black ఏనా? Which one okay? Yellow or white? Which one is visible? Which color is visible? Okay, the semiconductors. Basically the semiconductors are two types. One is pure and impure. Pure and impure. Okay. First, pure semiconductors and impure semiconductors. Before getting into this pure and semiconductor classifications, now the evaluation of electronics. Evaluation of electronics. See, in the olden days, there is no semiconductor devices. That is the only vacuum tubes. You can watch the old movies. You will get the some electronic components, vacuum tubes. Okay. For example, did you see the PN junction diode? Anyone in the laboratory? Okay, that is a small size. Now you can take the in 19th century. So you can take the one vacuum tube. Size should be one vacuum tube is this much. So if you are making the more devices and if you are make the any other component, if you are using this in the any other gadgets, then what will happen? The size, that size also will increases. So the first electronics were introduced in 1904. That is a vacuum tube. The vacuum tube is introduced in 1904 by John Fleming. The John Fleming scientist invented the vacuum tube. Okay. Now, in that vacuum tube, they are using the one electrode. For that electrode, they are connecting the filament. If the filament is charging, that electrode is generating the electrons. That is a process in the vacuum tube. Okay. Now that device can allow the flow of electrons. That is the generating the electrode is the generating the charge carriers. That is the electrons by increasing the filament temperature. Okay, so there is a vacuum tube. In the 1907, that is 1904, that is a vacuum tube is the thermi-ionic diode. That is a diode. Okay, diode means the two ions, positive ions and negative ions. In the 1907, the triode was introduced by Lee D. Forest. The triode is introduced by Lee D. Forest. And in the 1945, these vacuum tubes, because of this size of the vacuum tubes, that vacuum tubes are replaced by solid state devices. In 1945, the vacuum tubes are replaced by solid state devices. This can be done by the Bell Laboratories, America. The Bell Laboratories, USA. Okay, next in 1945. In 1947, the ICs, integrated circuits, the concept was introduced. In the 1947, in the 1947, that transistor was introduced. Okay, in the 1904 diode, in the 1907 triode, and in 1945 that can be replaced by the vacuum tubes or replaced by the solid state devices. And in 1947, transistors. The transistors are invented by the three scientists. The one scientist is the Shockley. Okay, and Brattain and Bardeen, the three scientists, Bardeen, Brattain, and Shockley. Okay, in 1952, the IC technology was introduced. Hello. Hello. Now, in 1952, the IC technology. That is the integrated. Is it clear voice? Voice is clear. Okay. In 1952, the IC technology was introduced. Okay. In 1957, okay. In 1957, okay. In 1957, the IC technology was patented. Do you know the patent meaning? If you are manufacturing any device or if you are having any idea, that idea is to be becoming a prototype model. Okay, now we can patent that. So that on that patent, on the device, you have the own rights. No one will become the duplicate. Okay, so the IC technology was introduced in the 1952, but that was patented in 1957. Okay, and after IC technology, what is IC? Integrated circuits. Okay, in that integrated circuit, we are in the again the semiconductor device. We will understand now. Okay, now after 1957 and the 1974, in the 1974, the nanotechnology was introduced. Because of that nanotechnology, our mobile phones, the day to day, it will become the smaller. Because of the nanotechnology, our laptops and mobile phones or smartphones or any other electronic gadgets become the smaller in size because of the nanotechnology. Okay, so that is the evaluation of electronics. Now coming to the semiconductors. So in these semiconductors are the semi between the insulator and the conductor. That's why the name is called a semiconductor. If the temperature increases, that can act as a conductor. If the temperature decreases, that can act as a insulator. Okay, so that is a semiconductor. Now that semiconductors are classified in the two types. Is the pure semiconductors. The which atom you are taking from the periodic table, that is the fourth group elements. That fourth group elements are the pure semiconductor. That is the carbon, silicon, germanium. Okay, now that is called the pure semiconductor. These pure semiconductors are also called intrinsic semiconductors. Intrinsic semiconductors. The intrinsic means the pure semiconductors. Intrinsic semiconductors. That is pure. And impure is pure semiconductors plus the two types. One is the trivalent and pentavalent. The trivalent impurities and pentavalent impurities. The trivalent impurities means these elements are having the valence electrons are 3 valence electrons. Means if you are taking the one atom, this is the one atom, this is the neutron, and here this is the, what is this? Helium, and this one is neon, and this one is argon. Now our fourth group elements, or you can take the trivalent means. So after this, for example, this atomic number is the 2. Now we can take the 5. Atomic number is, that is the boron, right? The boron atomic number is the 5. That is the boron is having the valence electrons or 3 valence electrons. Those elements are having the 3 valence electrons. That elements are called trivalent. Okay, that means these 3 electrons here, or you can take the another one, aluminum, that is the 13, the 13 here. 13, the 3 valence electrons. That means the 10 electrons are in the covalent but strong bond. So that those electrons we can't break. That's why the helium, neon, and argon we can't break. Okay, those are the noble gases. Now, if the aluminum is having the 13 atomic number, so that means the aluminum is having the 3 valence electrons. Okay, so those elements are called trivalent elements. And now, pentavalent elements. The pentavalent elements are having the valence electrons are 5. The valence electrons are 5. That 5 electrons are free. Okay, so now here we are in the one word doping. How we are getting the impure semiconductors? That is the extrinsic semiconductor. The extrinsic semiconductors are the combination of the pure semiconductors and impurities. That impurities are the trivalent impurities and pentavalent impurities. The trivalent impurities are the third group elements of the periodic table, and the pentavalent elements are the pentavalent impurities are the 5th group elements of the periodic table. You can remember the trivalent are third group, the pentavalent are 5th group. The trivalent are having the 3 valence electrons and pentavalent 5 valence electrons. Now, see, these impurities we are adding to the pure semiconductor. Now, the process of adding the impurity to the pure semiconductor is called doping. What is the doping? The process of adding impurity. That impurity may be trivalent or pentavalent to the pure semiconductor is called the doping. Okay, so after doping, we are getting the extrinsic semiconductors. Now, these extrinsic semiconductors only we are using to make the diodes and transistors, that is the electronic devices. The diodes, transistors, and integrated circuits. The integrated circuit means you are using the mobile phones, and in that the memory is 16 GB RAM, 16 GB RAM, 64 GB read-only memory, storage memory. That using these electronic devices only. Okay, that electrons are the extrinsic semiconductors. That is the adding. Now, these extrinsic semiconductors are the 2 types. One is P type and the N type. The extrinsic semiconductors are the N type semiconductors and P type semiconductors. Okay, now coming to the extrinsic semiconductors. One is the P type. Listen, P type semiconductor and N type semiconductor. The extrinsic semiconductors are P type and N type. The P type, if you are adding the trivalent impurity to the pure semiconductors, then will make the P type semiconductor. So this is the pure semiconductors plus the trivalent impurity. The pure semiconductors and the trivalent impurities. Now you can take the one pure semiconductor, that is I will take the pure semiconductor is germanium. The germanium is having the how many valence electrons? Now I will mark the valence electrons here. Four valence electrons. The germanium is the 4 valence electrons. Now we are adding the trivalent impurities. Right? The trivalent impurities. What are the trivalent impurities? Take the aluminum. Aluminum is having the how many valence electrons? 3 valence electrons. Now you can mark these 3 valence electrons. Okay. Now by combining the pure semiconductors and impurities, then the pure and the impure can share the electrons. I am having the 4. You are having 3. You can give me 3 electrons. I will make a argon noble. So that means the pure and the impure, the pure semiconductors and trivalent are the forming a covalent bonds by sharing the electrons. Okay, now these are the sharing like this. One covalent bond. Right? If the electrons are in the covalent bond, we can't break. If you are applying the voltage also, high electric field also, right? So that's why it is forming the sharing the one electron, and here another germanium is having the one more covalent bond, and here germanium, here one more covalent bond, and here the one more germanium is having 4, and here this is forming another 4. Right? Both are having one electron less. Aluminum దగ్గర ఎన్ని ఉన్నాయి? 3 ఉన్నాయి. 3 జర్మనీకి ఇస్తే ఎన్ని అవుతాయి? 17 అవుతాయి. But that is not argon కాలే ఇంకా 18 కాలేదు. 18 is the argon atomic number. So it is forming the 4 covalent bonds. Then that this germanium got the insulator. But here the one electron is required to form a covalent bond, 4th covalent bond. So that required electron we are calling as a hole. Some hole is there. That means that is required one electron. Now this hole is acting as a charge carrier. Charge carrier. That is the free hole that can move. By applying the electric field to that semiconductor, that free hole can move. And but these covalent bond electrons can't move by increasing the electric field. Right? But it can move because this is the free. So that means the p-type semiconductors are having holes. Hole means that is required of one electron to form a covalent bond. Okay, so that hole we are calling as a charge carrier in the p-type semiconductors. So in the p-type semiconductor, the holes are majority charge carriers. That holes are acting as a charge generating, the charge carriers. What is the carrying? Charge carrying devices. So the charge carrying elements are here, holes. Okay, so in the p-type semiconductor, what we are having? The majority charge carriers are holes. This whole polarity is positive. Everyone remember? The whole polarity is positive. The whole polarity is positive. Okay. Now, and the minority charge carriers are very, very less here. That is electrons. The electrons can be denoted as this. Or the holes can be denoted as the plus or simply. Okay, the electron charge is the negative. Okay. Now coming to the n-type semiconductor, here also you can take the same germanium, and the germanium is having the 4 valence electrons. Now for this 4 valence electron, now you can add the impurity. Which impurity we are adding? Pentavalent. Tell me the one pentavalent element. Nitrogen, phosphorus, and okay, You know the already only phosphorus, and another one is the arsenic. That is abbreviated as AS. So I will use the phosphorus. Okay. So this phosphorus is having how many valence electrons? 5 valence electrons. Now the germanium fourth group element and the fifth group of element phosphorus are sharing the 4 electrons. Yes. Right. Now, so by combining the pure semiconductors and impure, that is the pentavalent impurities. Now the pentavalent impurities are having the 5 valence electrons. In that 5 valence electrons, the 4 valence electrons of the pentavalent impurities are sharing with pure semiconductor, that is a germanium. Now by sharing, so the 4 covalent bonds will form. After forming the 4 covalent bonds, how many free electrons are there with the phosphorus and semiconductor? One extra electron. Now this electron is acting as charge carrier. It is acting as charge carrier. That charge carrier is polarity is negative. That can be denoted as electron. E hyphen. Okay. So now these are the semiconductors. That is the N type and P type. Now here by increasing the temperature, the already the here covalent bonds are in bond only. Now it acts as a conductor. Okay, conductor means it allows the flow of electrons. Now the electronic devices are it allows the or it controls the flow of current. What is the electronic devices? It controls the flow of current in the devices. Those devices are called the electronic devices. Okay. Shall I keep? So the two types of semiconductors. Yes. Well, the session is going on. In between, I will ask the questions. Be ready for that. So don't be sit ideal. Okay. Next. Erase last of 5 election jala. Okay. Over. Now, using these semiconductors, now we are designing the, or we are making the semiconductors devices. Okay, the first semiconductor device is that is a PN junction diode. The first one is the PN junction diode. The PN junction diode. Now, so in the PN, so to make the PN junction diode, we are using the two types of semiconductor. There is a P type as well as N type. Now, you can take one crystal bar. You can take the one crystal bar. Now, in this crystal bar, you can divide into the two parts. One side of the crystal bar, you can add the trivalent impurities, that is the P type, and the other side of the crystal bar. What is the crystal bar here? The pure semiconductor, that is a germanium or silicon. Okay, so now other side of the crystal, you can add the N type, that is the pentavalent impurities. The previous, we are made that separately, the P type semiconductor and the N type semiconductor. Now, of equal parts. Okay, then we are adding the P type trivalent impurities here and the pentavalent impurities.
See, after sharing the some electrons from the P to N, and some electrons is accepting from the N to P, ions are developed. At the P side, the P-type semiconductor, the negative ions are formed. That is called the acceptor ions. And at the P side, N side, the positive ions will develop. That is called the positive ions. That is the donor ion. Now, this donor ion and acceptor ion will form a barrier. You know the barrier? This is the barrier for us. You can't go beyond that wall. That is a barrier for you, right? Or this way also barrier for girls and boys, right? So no one will. So here the no further electrons are shared with the p-type semiconductor. After forming a barrier, that barrier is called the potential barrier. Okay, so now here we are applying the any electric field or voltage for that PN junction. No. Okay, simply we are joining, or simply we are taking the one crystal bar. So in that crystal bar, one side we are adding the p-type semiconductor, and other side we are adding n-type semiconductor. Then that will form a p-type and n-type. So now because of this joining, the sum of the electrons are sharing with the p-type semiconductors. Okay, now here some immobile charge carrier will form. This side the donor ions, and this side acceptor ions. If we could only here between the N and the p-type. Now this is called the depletion region or potential barrier. What is this distance? The depletion region, the potential barrier is called junction. It is called junction. That junction we are calling as a PN junction. Okay, and this PN junction is having, how we can apply the electric field? By connecting the voltage, batteries. So for that we are using the one terminal. On the one contact terminal we are connecting to the p-type semiconductor. Another contact material we are connecting to the n-type semiconductor. And these terminals are called as the anode and the cathode. Okay, now this is the formation of the construction of PN junction diode. Right? Everyone understood? Yes, lost. The PN junction diode construction and how the junction is forming without applying. Last one. Okay, this is the construction of how we are constructing the PN junction by joining the p-type and n-type semiconductor. Or you can take the one crystal bar. One side you can add the trivalent, other side pentavalent. Okay, after forming, the some carriers are sharing. Donating is called the donor ion, accepting is called the acceptor ion. So now this positive ion, negative ion form a barrier, some wall between the n-type and p-type. That wall or that barrier we are calling as a depletion layer or depletion region or the junction. That junction we are calling as a PN junction diode. PN junction diode. Why it is called the diode? Di means what is the two? Iode. Ions. What are the two ions? Positive ion and negative ions. Because of that, construction is called the PN junction diode. Now the symbol of this PN junction diode is, this is the anode and this one is cathode. This is the arrow symbol. Arrow. And this is arrow. And this one is, what is this? This is called junction. That arrow shows the conventional current direction. How the current is flowing in the PN junction diode. That direction is shown by the arrow. Okay, the arrow indicates the current conventional direction. Current direction in the PN junction. How the current is flowing. That is a positive direction. Okay. Now, if the both are separate, no ions, no concentrations. Okay, if both are joining, then ions will form. That is due to that ions, the barrier will form. That barrier we are calling as a PN junction. How many junctions are present in the PN junction? How many junctions? only one junction between the p-type semiconductor and the n-type semiconductor, right? Okay, now this is the construction. Now we can apply
సార్ బొమ్మ రావట్లేదు.
okay, yes. Okay, now after construction, then screen share. ఎందుకు వస్తుంది అది పైకనే చేయండి కంప్లీట్గా పైకి. Okay, now you can see here. Okay, now we can take the one PN junction diode. I will draw the using the junction also diode symbol also. I will draw the circuit diagram. Now we are taking the PN junction diode construction diagram. Now at the ideal, without applying the any electrical field or any connecting the any external power supply, that is a battery. So here the junction is formed. That junction we are calling the PN junction. Now you can apply here some external voltage. Apply some external voltage. What is the symbol of this? What is the symbol? Battery. The symbol of battery. Now the battery is having, but battery supply is the DC supply or AC supply? DC supply, not AC. The AC supply is this fans and switchboard. The which power is present in the with the switchboard, that is the AC, alternating current. This is the direct current. Okay, so DC, the battery gives the output voltage is DC. Now we are connecting the battery to the electronic device. And one more point, all electronic devices are operate with the DC only. Our mobile phone also, our laptops also, all are operate with DC supplies. Why the device or DC supply, you can understand later. So now you can connect some external battery to that PN junction. The construction of the PN junction. The positive terminal is connected to the P-type semiconductor, and the negative terminal of the battery is connected to the N-type semiconductor. Okay. Now you can remember the magnetic principle. What is the magnetic principle? South pole will repulse, and south or north will attract. North or north will repulse. The same principle here also we are applying. So now the positive terminal of the battery, that is the positive charge. Okay, that is connected to the P-type semiconductor, and the negative terminal of the battery is connected to the N-type semiconductor. The P-type semiconductors are having the charge carriers, or what are the charge carriers in the P-type semiconductor? Are holes. That is the positive charge. Holes are positive charge. So here the positive charge we are connecting, and here the positive terminal of the battery. What will happen in the between the positive and positive? Will repulse. బోర్డు చిన్నగా ఉంది కదా. బోర్డు పెట్టండి, బోర్డు దీంట్లోనా, జూమ్లోనా? జూమ్లో మీరు మొబైల్ స్క్రీన్ షేర్ చేయాలి. స్టార్టింగ్లో వచ్చింది, ఇంటర్నెట్ స్లో అయిపోయింది, దాంతో ప్రాబ్లం. Okay, listen. If the positive charge, that is the P-type semiconductor, is connected to the positive terminal of the battery, ఏమవుతుంది? Positive will repulse. Now what is the whole direction? Towards battery or out of the battery? P లో ఉన్న హోల్, P-type semiconductor హోల్ ఎక్కడ మూవ్ అవుతుంది? Towards junction, towards N-type semiconductor. But between the P-type and N-type, some barrier is there. That barrier is the depletion layer, depletion region. So that hole is moving towards depletion region. Okay. Now coming to the N-type semiconductor, the N-type semiconductor is connected to the negative terminal of the battery. Right? That negative charge, now battery is having the negative charge, and the electrons, N-type semiconductors are having the charge carriers or electrons. That electrons also negative charge. Negative and negative will repel. So now the whole electron, this is the junction. Okay. Now the electron is moving because of the repulsion from the battery negative terminal. The electron is moving towards barrier, and the hole moving towards barrier. Now the pressure applied on the barrier. Then what will happen in the barrier? the barrier width will decrease. Now we can increase the power supply at the battery. Then what will happen? Again, the electrons can move faster, and electrons and holes can move faster. Some more pressure on the barrier. At certain voltage of the applied voltage, the barrier will width decrease and thin. At the certain voltage, the barrier will remove, and the electron can cross from N type to P type, and holes can cross from P type to N type. What is the current? Current is flow of electrons. So now in this biasing, this is called the biasing. So in this process, the electrons are moving, the holes are also moving, both are crossing the junction. N type to P type and P type to N type. So the electron movement is there. So that means the current is conducting. The diode is in the conduction. That means the conduction means it is allowing the flow of electrons. So that's why the electronic devices are controls the flow of current. Because of this reason, electrons are the current. Electrons are or current is controlled by the device. Okay. Now still, if you are increasing the applied bias voltage, battery voltage, so the almost all the barrier width will disappear, and the electrons and hole moves freely. That can be acts as a good conductor. Okay. So that biasing is called the forward bias. Now, what is the forward bias? Anyone can answer what is the forward bias? Simply, the battery positive terminal is connected to the p-type semiconductor. The battery negative terminal is connected to the n-type semiconductor is called forward bias. So in that forward bias, the junction width is decreasing. Okay. Now this is called the forward bias. What is the forward bias? This process. This process is called forward bias. Okay. So in this forward bias, how the voltage, how the diode starts conduction, will understand now. So if you want to note down, you can note down this. Make it first. Okay, now ఈ diagram మళ్ళీ draw చేయాలని చెప్పారు. Okay, now you can diode is in corrected forward bias, right? Now in this forward bias, apply the 0 volts. This is called forward voltage. If the diode is in forward bias, that applied voltage is called forward voltage. Okay, now you can apply the, simply you can connect the battery. You can apply the 0 volts. What will happen? No current. No current will flow because the battery is connected, but the power is voltage is not applied. Now you can slowly, you can increase the voltage. 0.1 volt. Because of that 0.1 volt, this positive volt is repelled by the positive terminal of the battery, and the negative charge, that is the electron, is repelled by the negative terminal of the battery, but very slow. So if it starts moving like this, the hole is moving to N-type and electron is moving to P-type semiconductor. Now we can increase the voltage here also. 0 current. The current is, you can take the milliamp. Okay, now we can increase 0.2 volt. Again it will move here and here. Now some force is applied on the barrier. Some force is applied, and you can apply the 3 volts here also, 0 amps here. Now at the 0.2 volt, some barrier width decreases. If you are increasing the applied voltage, that is the battery voltage, the barrier width will become thin. So from the thin region, some electrons will cross the junction, not all, only few, because of the some layer is there, thin layer is there. Okay, because of thin layer, only the few electrons are moving from N-type to P-type, and few holes are moving from P-type to N-type. Because of that, the current will get here. Some current is flowing. Okay, now you can increase the voltage again here, 0.4 volt. The voltage current can increase. Now you can apply the 0.5 volt, then the current can increase. You can apply the 1 volt, you can increase, the current will increase. At certain voltage, the total diode junction will collapse. The total junction barrier width will collapse. Easily the electrons and holes can move easily from one direction to other direction. Okay, so how much current is present in the battery? The total current can be flowing through the diode. Okay, that is called forward bias. Now where the diode starts conduction, for which applied voltage the diode is started conduction, that voltage is called cut-in voltage. This voltage is called cut-in voltage, or is also called knee voltage. Okay, for which applied voltage under forward bias, for which applied voltage the diode starts conduction. Conduction means allowing the electrons. The starts conduction, that voltage is called cut-in voltage or knee voltage. This voltage is different for the germanium and silicon. What is the atomic number of silicon? 14. The germanium is more than silicon. Now you this is the neutron, this is the silicon, and this one is, for example, neutron. The neutron power on which valence electrons is more? The silicon valence electrons or germanium valence electrons? కొందరు వెనక బ్యాక్ బెంచ్ లో కూర్చుంటారు ఎందుకు? Why students are sitting in the back bench? ఫ్యాకల్టీ ఇక్కడ ఉంటాడు, అక్కడికి వెళ్ళే వరకు టైం పడుతుంది, అంతే కదా? చూస్తే ఇట్లా చూస్తాను, అలా చూస్తే వాడు నన్ను చూడట్లేదు, తల దించుకుంటాడు. అంటే ద మోర్ కంట్రోల్ ఆన్ నియర్ స్టూడెంట్స్, ద లెస్ కంట్రోల్. And similarly here also, if the which atom is having the less atomic number, the valence attraction of the neutron power on valence electrons are more, because the radius is less. The which atomic number is more, that valence electrons attraction of the neutron is less. Okay, so we can get easily the silicon valence electrons, sorry, germanium valence electron, because there is a large atomic number, and silicon is a 14 only. There is a more power of the neutron on valence electron. So the germanium is having the cut-in voltage is the 0.3 volts. Okay, because of low attraction of the neutron. Okay, so the cut-in voltage of the silicon germanium is a 0.3 volts, and the silicon is 0.7 volt. The silicon is 0.7 volt. Now we can try to draw the VI characteristics for this. Here. Okay. Now we are drawing the VI output characteristics, or the voltage ampere characteristics of the PN junction diode. Okay. That is drawing the graph. Here we are having the two parameters. One is the voltage and current. The which parameter on the x-axis and which parameter on the y-axis? Voltage on x-axis, current on y-axis. Why not reverse? Why not reverse? Current on x-axis and voltage on y-axis. Answer is correct. There is a x-axis we are taking the voltage, on y-axis we are taking the current. But why not reverse? What is the reason? Anyone knows? In mathematics. Okay. If you are drawing the graph, always you can take the independent variable on x-axis and the dependent variable on y-axis. So in our case, what is the independent variable? Voltage. By applying the voltage, the current in the diode is changing. So that is the output. So always take the input on x-axis, output on y-axis. Okay. So here the output applied input applied voltage, that is called the forward voltage, because the diode is in the forward bias. Okay, forward voltage on x-axis and current in y-axis. Okay. Now here generally I will draw the graph now with the measurements. This is the origin point, 0 volts. Now if you are increasing the voltage, the electron is not crossing immediately. మనం సడన్ గా 5 volts ఇవ్వం కదమ్మా, వీఆర్ ఇంక్రీజింగ్ స్లోలీ. సడన్ గా 5 తిప్పేస్తాం ఇక్కడ, లేదు కదా. తిప్పాలంటే 0.1, 0.2, 0.3, 1, 2, 3, 4, 5 అలా ఇంక్రీజ్ చేస్తూ పోతాం. సడన్ గా అయితే 5 పెట్టాం. దట్ ఇస్ నాట్ ద బటన్, దట్ ఇస్ ద screw type rotator. Okay, so slowly we are increasing. So if you are increasing the applied voltage, the diode will not conduct because of the barrier is present. Okay, now if you are increasing the voltage, what is the meaning of this? We are at here now. What is the meaning here? I am applied this much voltage, but the current is 0. There is no current in the diode. Now at certain voltage, the diode starts conduction. This voltage is the 0.3 volt, that is 13 voltage. 13 voltage or knee voltage. So for which voltage, for what voltage the diode starts conduction, that voltage is called 13 voltage. So now we can increase the voltage, the current will increase. ఇక్కడ స్లోగా ఇంక్రీజ్ అయింది, ఇక్కడికి వచ్చే వరకు ఫాస్ట్. Whole current will flow through the diode. Okay, so now this characteristics is the germanium diode. Now you can take the silicon diode. This is 0.7. 0.7 volt. After 0.7 volt, the diode starts conduction. Okay. So this is the forward bias characteristics. In the forward bias characteristics, the diode starts conduction characteristics. Okay. Now positive terminal of the battery, sorry, negative terminal of the battery, and electrons are attracted by the positive terminal of the battery. So electron movement undi, hole movement undi. Huh? What is the current? Huh? Flow of electrons. In the reverse bias, current enta? How much current in the reverse bias? 0. మీకు పాయింట్ అర్థం కాలేదు. The current definition is flow of electrons. The current definition is flow of current. Flow of electrons is called the current. Okay. Now the diode is connected in reverse bias. In this reverse bias, the electrons are moving towards battery. Electron movement unda? The electron is moving towards battery, positive terminal, and holes are moving towards negative terminal. Hole electron ideally alane unnaya, move avutunayi. Then what is the current in the diode? Negative current. Huh? No current. Neutral. How can you say neutral? Okay, see, a small example I will tell you. One canal is there. For canal, one side, one village is there. Other side, here A village and B village is there. One big canal, there is no bridge. The people can cross the canal swimming anakandi. Cross chestara? No, because some barrier is there. అంటే అందులో ఉన్న వాళ్ళు అందులోనే కలుస్తుందో తప్ప వేరే వాళ్ళు మూవ్ కావట్లేదు. దెర్ ఇస్ నో ట్రాన్స్పోర్టేషన్ ఫ్రమ్ ద ఏ సైడ్ టు బి సైడ్. సో దట్స్ వై ద కరెంట్ ఈజ్ 0. అంటే కొందరికి డౌట్, చాలా మంది డౌట్స్ అడిగారు, సార్ మీరు కరెంట్ అంటే ఫ్లో ఆఫ్ ఎలక్ట్రాన్ అంటున్నారు, బట్ ఎలక్ట్రాన్ ఎన్ టైప్ నుంచి ఎన్ టైప్ సెమీ కండక్టర్ నుంచి బ్యాటరీ వరకు వచ్చింది కదా, అది మూవే కదా, మూవ్మెంటే కదా అన్నారు. అంటే దానికి ఎగ్జాంపుల్, ఒక విలేజ్ లోనూ వాడు అక్కడక్కడే తిరుగుతుంటాడు, నో యూజ్, మనకి ఏమైనా పని దొరికితే అక్కడ తిరిగితే, వాడు అటు ఇటు తిరిగితే అక్కడ ఉండే వాళ్ళకి జాబ్లు కానీ ఏమైనా వచ్చే ఫెసిలిటీస్. సో హియర్ దట్ ఈస్ టేకింగ్ ఎగ్జాంపుల్ ఓన్లీ. సో హియర్ ఆల్సో there is no electron is crossing the junction, the no hole is crossing the junction. Okay, so that's why the current in the PN junction diode under reverse bias is 0. Okay, now but the some current is present. మొబైల్ ఫోన్ అడాప్టర్ చూసారా? ఒక హాఫ్ అన్ అవర్ ఛార్జ్ ఆన్ చేసిన తర్వాత, ఛార్జింగ్ కనెక్ట్ చేసి హాఫ్ అన్ అవర్ ఆన్ లో పెట్టిన తర్వాత దెన్ యూ కెన్ టచ్ ద బ్యాటరీ. ఏమవుతుంది? బ్యాటరీలో హీట్ వస్తుంది. దట్ మీన్స్ ఇఫ్ యు ఆర్ ఇంక్రీజింగ్ ద పవర్, వాట్ విల్ హ్యాపెన్? ద పవర్ డిసిపేషన్ ఇస్ దేర్, హీట్. Okay, because of that heat in the PN junction, that is the P type and N type semiconductor. Listen carefully, this is a very, very important. Because of that heat, power dissipation in the PN junction diode already formed covalent bonds. Any covalent bonds P type lo? 3 covalent bonds other than neon, noble gases. Okay, the 3. And N type, 5 covalent bonds. There is a chance of breaking this covalent bonds by increasing the voltage, by increasing the temperature. How we are increasing the temperature? By applying the power supply, battery voltage. Okay, so now that due to that temperature already formed covalent bonds in the P type semiconductor and covalent bonds in the N type semiconductor, some bonds can break. If the covalent bond is breaking, then what will happen? Free electron holes, free electron holes. Listen carefully. Okay, due to this this carriers, there is no current in the reverse bias. Listen carefully. There is no current in the reverse bias. Okay, now we can take the PN junction, same PN reverse bias Okay, reverse bias, positive, negative, positive. Due to temperature increase, due to voltage increases, more power dissipation at the diode. Due to that power dissipation, the PN junction diode get heat up. The PN junction diode can heat up. Due to that heat, the already formed covalent bonds will break. If this here also, here the covalent bonds, these bonds will break, then the electrons and hole pairs are generated. In the reverse bias, due to temperature increases, the already formed covalent bonds will break. Due to that break of covalent bonds, the free electrons and hole pairs are generated, and here also free electrons and hole pairs are generated. Electron hole pair ante one covalent bond is breaking, one electron and hole can generate. That is called the electron hole pair. Pair ante two. So now the battery we are not removed. Battery still we are connected and we are applied the voltage. Now this after breaking the covalent bonds, what will happen in the PN junction diode? In the p-type semiconductor, electron hole pairs are there, right? In the p-type semiconductor, the electron okay. So by here you can see by breaking the covalent bond, the free electron and hole pairs are generated. Listen. Okay, this is not the actual carrier of the PN junction diode. This is also not actual carriers. By breaking the covalent bonds, the free electron hole pairs are generating. Now, this negative term of the battery is repelling this electron. Okay, what is the electron in the p-type semiconductor? Minority charge carrier. In the p-type semiconductor, the majority charge carriers are holes. Minority charge carriers are electrons. Now this negative, that is the minority charge carriers are moving towards depletion region. And here this hole also moving towards depletion region. Okay, if you are increasing the voltage, then some electrons and holes can cross the junction by increasing the voltage. That voltage or that current, this now the electron free holes are moving from N-type to P-type semiconductor. That current is called reverse saturation current. This is a very, very important for the exam point of view or in the competitive exams. The reverse saturation current, because of that breaking of covalent bonds, the free electron and hole pairs are generated. That in that free electron and hole, the electron is a minority charge carrier in the p-type semiconductor that can move towards depletion to n-type semiconductor, and the hole in the n-type semiconductor can move towards p-type semiconductor. So the electrons and holes movement is there through the junction. That current is called reverse saturation current. Okay, now this current is called reverse saturation current, that can be denoted as I0, I0, I suffix 0. Okay, so that is the reverse saturation current. Now coming to the graph, I've done the same graph or different graph. Okay, we'll take the different graph for the forward bias and the reverse bias. Now we can draw the graph. Okay, now we are drawing the reverse bias VI characteristics. Reverse bias VI characteristics. Now, where we'll draw the graph? Tell me. Which voltage we are applying? Forward voltage or reverse voltage? Reverse voltage means negative voltage. If you are changing the battery terminals, that will give the reverse voltage means negative voltage. If you are doing that, taking the any DC component, for example, your mobile phone adapter, మీకు C type కన్నా ముందు ఒక చార్జెస్ వచ్చాయి గుర్తుందా? B type. ఓకే, అది 2 డైరెక్షన్ లో కనెక్ట్ చేయగలమా? Why? Because one is the positive terminal, other one is negative. So while connecting the power supply, you can connect the positive to positive, negative to negative only. If you are connecting the reverse, your mobile phone will damage. అందుకే ఆ వేలో దానికి కనెక్టింగ్ పోర్ట్ ఇచ్చింటాడు. ఇప్పుడు C టైప్ వచ్చింది, ఆ C టైప్ లో పాజిటివ్ నెగిటివ్ ఉంది. వాడు అలా డిజైన్ పైన దాన్ని పాజిటివ్ అన్నాడు, లోపల ఉన్న దాన్ని నెగిటివ్ అన్నాడు. సో మీరు ఇలా కనెక్ట్ చేసినా పాజిటివ్ నెగిటివ్ కనెక్ట్ అవుతుంది, ఇలా కనెక్ట్ చేసినా పాజిటివ్ నెగిటివ్ అవుతుంది C టైప్ కి. రైట్? Okay, now here if you are changing the battery direction, that will give the negative voltage. So where you are taking the negative voltage? In the third quadrant. Reverse voltage, and here that gives the reverse current. Okay, now what is the current direction in this? What is the current direction? Current direction ela untadamma general ga? What is the current direction? Flow of current definition is the flow of electrons. The current definition is the flow of electrons is called the current. Now what is the current direction? What is the, in which way we can show the current direction? Current direction. You can remember the current direction is always opposite to electrons. The current direction is opposite to electron direction. You can remember if fish water relation. Fish water ఎలా మూవ్ అవుతుంది? డౌన్వర్డ్స్. ఫిషెస్ ఎలా మూవ్ అవుతాయి? అప్వర్డ్స్. అంటే ఎలక్ట్రాన్స్ అన్ని అప్ వెళ్తే వాటర్ కిందికి వెళ్తుంది. ఓకే, సో వాటర్ ఈస్ current here, the electrons are fishes. Right? So now the water current is always flow of opposite to electron direction. Now what is the current direction? Tell me in terms of P type or N type. P2N or N2P. What is the electron direction? Electron direction. Yes, the electron is moving this. The current is reverse. So negative current. So now here, if you are applying the reverse voltage, then what will happen? The current is 0, right? Actual current in the PN junction diode under reverse bias is the 0. But if you are increasing the reverse voltage due to power dissipation, the covalent bonds break. Due to that break of covalent bonds, some current will there. That current is called reverse saturation current. So this is the reverse saturation current. Now, yes. Now still, if you are increasing the reverse voltage, అప్పుడు ఏమవుతుంది? డయోడ్ ఏమవుతుంది? డయోడ్ హీట్ ఎక్కువైపోతుంది. హీట్ ఎక్కువైతే ఏమవుతుంది? బ్రేక్. That at what voltage the diode is break, that voltage is called breakdown voltage. So how many points we got now here? The cut-in voltage in the PN junction diode construction and operation under forward bias and reverse bias. Under forward bias, cut-in voltage. At what voltage the diode starts conduction, that forward voltage is called cut-in voltage or knee voltage. Coming to the reverse bias, at what voltage the diode will get damaged, that voltage is called breakdown voltage. Okay, that voltage is called breakdown. So now this is the reverse bias BI characteristics. Okay, now using this reverse bias and forward characteristics, we are defining the resistors. Diode resistance. The diode resistance. What is the resistance? Anybody can define the resistance? Resistance definition? Huh? It opposes the flow of electrons. That is the definition. Okay. Now define the resistance in terms of voltage and current. The voltage defined as the ratio of voltage to current. That is V is equal to, sorry, R is equal to V by I. The general definition is the property of the resistance is it opposes the flow of electrons. What is the symbol of resistance? Symbol. And you can show the symbol. Symbol ela undamma? What is the meaning of that? Why the symbol given to that symbol is given to resistance? రోడ్ మీద ఏముంటాయి? స్పీడ్ బ్రేకర్స్ ఉంటాయి కదా, ఎన్ని ఉంటాయి? ఎక్కువ ఉంటాయి. ఎందుకు? ఒకటి అది ఎక్కువ ఉంటే that will stop the speed, that will control the speed. Here also the flow of electrons can be controlling, stopping, opposing the flow of electrons. So that device is called the resistance. Okay. So now the resistance is defined in terms of the voltage and current is the V is equal to R is equal to V by I. Now these resistances are defined so the VI characteristics under forward bias. Under forward bias, first resistance is the DC resistance. The DC resistance is here the applied voltage by current IF. You can take the graph. Okay, now here this is the PN junction diode VI characteristics under forward bias. Now can take the particular here. Okay, so how much current is present, how much voltage is present? So that is called the DC resistance or static resistance. The DC resistance or the static resistance. Another resistance is there, that is dynamic resistance or AC. The dynamic resistance means you can take the 2 points, one point here, other point here. Now you can take the change of this voltage by, sorry, change of voltage by change of current. Change of voltage by change of current. Now you can see the definition. Okay, so DC resistance, that is the forward voltage by forward current, and this is also called static. And the dynamic or AC resistance is defined as delta VF by delta IF. Change in the output voltage to change in the output current, or change in the voltage to change in the current is called the dynamic resistance. Or say in the practical analysis, you not required for this. The practical analysis, we are not considering the static resistance, we are considering the dynamic resistance. మీ క్లాస్ మొత్తాన్ని నాలెడ్జ్ చెక్ చేయాలంటే ఒక్కరు కాదు కదా, ర్యాండమ్ గా ఒక ఐఎమ్ ఆస్కింగ్ 3-4 members, then we will get the people or knowledge or not. Okay, so similarly here also, if you are taking the one point, that is called the static resistance. If you are taking the multiple points, the change of average, what we are taking here, average, the change in the forward voltage and the change in the forward current is called dynamic and static resistances. Now see, if the diode is forward bias, the diode is forward bias, listen carefully here, if you are connecting the negative and positive, positive, negative, right? After cut-in voltage, what will happen in the diode? ఏమవుతుందమ్మా డయోడ్ లో ఆఫ్టర్ కట్-ఇన్ వోల్టేజ్ 0.3 volt for germanium and 0.7 volt for silicon. the whole current will cross the junction. All electrons will cross the junction. That is the P to N and holes from P to N and electrons from N to P. Now, so after cut-in voltage, the diode can be acts as a short circuit. Simply you can remember, under forward bias, the diode allows the flow of electrons, right? So the flow of electrons means that can be acts as a short circuit. That can be acts as a short circuit. Short circuit means how much current is present in the battery, the whole current can pass the junction. Okay, so that is called the short circuit. So in this forward bias, the diode acts as a on switch. When the diode is acts as a on switch, on ante enti fan on unda off lo unda, on the switch it will rotate. So power supply, the current is flowing to the fan motor and motor will rotate. And here also, if the after cut-in voltage, if you are applying the voltage, the whole current can cross the junction. Okay, how much current is present here, the whole current can be appear here. Okay, that means the diode is acts as a short circuit. If the diode is acts as a short circuit, then that can be called as a on switch. So if the diode is in forward bias, ideal ga, the diode is in forward bias, the diode acts as a on switch. Now, if the diode is the reverse bias, diode is reverse bias, then you can connect the reverse bias. The diode is in reverse bias, negative, positive. Junction width increases. If the junction width increases, the diode is acts as a any current is flowing in the reverse bias junction? No current. Okay, so simply the diode is open. The diode is acts as a open circuit. This concept we are using in the next unit, that is under rectifiers. That rectifiers we are using in our mobile phone adapters and laptop adapters. This is the 230 volts power supply input we are giving and with the frequency of 50 hertz. Okay, now we are getting the output, this device pure DC. Here also this is acts as a positive and negative, or this one is the negative or positive. Okay, this one is the output. So in that we are using the rectifiers. So in that rectifiers we are using the diode as a electronic device. So in that also the electronic device is there. There is a diode, PN junction diode. Okay, so when the diode is acts as a forward bias, when the diode is acts as a on switch under forward bias. Okay, that is on switch, or simply you can call as a short circuit. Short circuit is how much current, the whole current can pass our diode. That is called the short circuit. Now in the reverse bias, simply the diode is not allowing any current ideally, but practically reverse saturation current is present. Practically the reverse saturation current, but ideally no current will flow. So that is simply open circuit. Now, so this is called off switch. Okay, now if the diode is in under forward bias, then what is the resistance? If the diode is in reverse bias, then what is the resistance? What is the I'm not asking a particular figure, 1, 2 ohm, or 3 ohm, or 5 ohm, or 1000, or 1 kilo, 1 mega. Tell me some quantity. If the diode is in forward bias, what is the diode resistance? Resistance unda akkada? Resistance ante it opposes the flow of current. Is it opposing the flow of electrons in the forward bias? No. That means what is the resistance? 0. So if the diode is in forward bias, the diode offers 0 resistance. Right? The diode is offers 0 resistance. If the diode is in reverse bias, how much resistance can be offered by the diode? No electron is crossing the junction. What is the meaning? What is the resistance in the under reverse bias? 0 అక్కడ అయిపోయింది. ఓకే, దాన్ని రెండింటికి అప్లై చేయలేము. Then is it allowing the flow of electrons? No. Slow వెళ్తారు, మనం కంట్రోల్ చేసుకోవాలని వెళ్తాం. But here, if the resistance is high, then no electron will cross. No electron will flow. So that means if the diode is not allowing any electrons, then the diode offers high resistance. The practically or ideally, it is 0 ohms. What is the symbol? Infinity. What is the infinity? Countless. Very high resistance. Okay, ideally, but practically, the diode also allows the current in the reverse saturation current, right? So now, but ideally, you can remember, if the diode is forward bias, that acts as a short circuit. Short circuit ante simply itla connection anatlu. ఇది ఎలా ఉందమ్మా? Both are connected or disconnected? Now this is the connection, means short circuit. Charge చేస్తుంది. మీకు కొన్నిసార్లు షాపింగ్ మాల్స్ లో ఫైట్స్ వచ్చినప్పుడు షార్ట్ సర్క్యూట్ వల్ల అంటారు. ఏంటి అక్కడ ఏదో వైరు డ్యామేజ్ అయ్యి ఆ వైర్ ఈ వైర్ కనెక్ట్ కావడం వల్ల సమ్ ఫైర్ విల్ జనరేట్ డ్యూ టు ద ఎలక్ట్రిక్ ఫీల్డ్. సో దట్ ఫైర్ విల్ స్ప్రెడ్. That is short circuit. So if you are joining this both, this is called the short. Actually here we kept this is the PN junction diode. Like this we are connected. Okay, by increasing the voltage, the junction width will decreases, the whole junction will disappear and both will connect here. Positive term the battery and negative term the battery. So this is called short circuit. Okay, so now if the diode is in forward bias, that can be acts as a short circuit. That means that acts as a on switch. If the diode is in the reverse bias, the reverse bias diode offers very high resistance. That is infinity ideally, but it offers mega ohms. Several mega, capital M. What is the capital M value? 10 to the power 6. So 10 to the power 6 ohms. Several, not only 10 to the power 6, the 2 mega ohm or 3 mega ohm or 1000 mega ohm or like that. Okay. So if the diode is the reverse bias, that offers a high resistance. So that's why the diode in the reverse bias can act as a open circuit. That can be act as a off switch. You can remember these 2 points. You want to break? 12, 30. 12, 10. 1 key కదా. 12 ki break. Okay. Yes. Now, this is the PN junction diode. Now, this PN junction diode can be used in the several these are having the several applications. Yes. Now, the PN junction diode can be applications of PN junction diode. This can be used in rectifiers. That topic also will discuss in our subject, that is the rectifiers. And the same PN junction diode can be used in to make a integrated circuits. Do you know the integrated circuits? Chip in pair black color lo untadi. Okay, black color only pins untai ila. 4 sides pins untai. That is called the chip. So to make that integrated circuits, we are using semiconductors. That is diodes. And the diodes can be used in the rectifiers, TVs, amplifiers, and many electronic gadgets. Okay. Now, see, this diode is having some limitations and some definitions. One is the maximum forward current. The maximum forward current. The maximum forward current means the how much current it will allows, maximum current it will allows. That current is called maximum forward current. Okay, beyond that current, that diode will heat. So diode will get damaged. Okay, that current is called the maximum forward current. And the next one is the peak inverse voltage. What is meant by inverse? Reverse. In which biasing we are applying the reverse voltage? Reverse bias. So under reverse bias, at what voltage the diode is withstand without to break? That maximum reverse voltage is called PIV, peak inverse voltage. One is maximum forward current, and the second one is PIV. The PIV stands for, this is a very, very important parameter for the diode. The PIV, the peak inverse voltage. Now, the maximum forward current means the maximum current allowed in the forward bias of the PN junction. That current is called maximum forward current. Next, the PIV. PIV is the reverse bias voltage. PIV is reverse bias voltage. The maximum reverse voltage applied to the PN junction diode without damaging the junction. That maximum reverse voltage is called peak inverse voltage. Peak inverse voltage. Okay. So these are the parameters for the, and along with this, the dynamic resistance and the forward dynamic resistance and the static resistances. Okay. Now, okay. Now, tell me the, can you identify the drawback of PN junction diode? Anyone? Huh? It doesn't work in the reverse bias. The PN junction diode does not work in the reverse bias. Simply, ideally, the PN junction diode under reverse bias we are calling as a open circuit. That is off switch, open. Okay. So because of that is the main drawback of the PN junction diode. That will work in the PN junction under forward bias perfect, but in the reverse bias that will not work. That is simply if the reverse voltage increases, that will get damaged. If you are increasing the reverse voltage, the diode will get damaged. Okay, that is the drawback of PN junction diode. Now, to overcome that drawback, the next diode is invented. That diode is called the Zener diode. The same, the functionality of the PN junction diode and the Zener diode both are same, but the PN junction diode does not work in the reverse bias. And coming to the Zener diode, this can work in the reverse bias also. How it is working? Because we are increasing the doping amount. Okay, in the PN junction diode, 1 or 2 atoms of impurity we are adding to the 10 to the power 6 pure semiconductors. 10 to the power pure semiconductors ki, and 1 atoms ki, how many impurities we are adding? 1 or 2 atoms. That is in the PN junction. That impurity levels are increased in the Zener diode. The remaining, the construction as well as the working operation, everything is same for the PN junction diode and the Zener diode. By increasing the reverse, by increasing the doping levels, impurities to the PN junction diode, that is called the Zener diode. Now the special function of the Zener diode is that works in the reverse bias also. Because of that reason, the PN junction Zener diode is having some extra applications, that is the beyond PN junctions. Okay. Break. Okay. Do you have any doubt on the PN junction diode? Is it clear? Last. మీ హెడ్స్ అన్ని డౌన్ లో ఉన్నాయి. Okay, if you are having any doubt in the PN junction diode construction and operation, you can ask me. In reverse bias? ఏది దానివల్ల జంక్షన్ కూడా హీట్ ఎక్కుతుంది కదా. జంక్షన్ కూడా హీట్ ఎక్కినప్పుడు ఎక్కడో దగ్గర గ్యాప్లు అయితే ఉంటాయి కదా, అంటే జంక్షన్ కూడా వీక్ అవుతుందా ఆ హీట్ వల్ల. ఆ వీక్ అవడం వల్ల కొన్ని ఎలక్ట్రాన్స్ మూవ్ అవుతాయి. అందుకే చాలా ఇది మిల్లీ యాంప్స్ లో ఉంటుంది, మైక్రో యాంప్స్ లో దానికి కౌంటబుల్ అన్కౌంటబుల్ కూడా. అవునా బాబు, కానీ హీట్ అవుతుంది కదమ్మా. దాని స్పెషల్ ఏంటి, మనం ఎందుకు ఆ కోవలెంట్ బాండ్స్ వస్తున్నాయి? హీట్ మీకు రెసిస్టెన్స్ కూడా హీట్ అప్లై చేయండి, దాని రెసిస్టెన్స్ పవర్ తగ్గుతుంది కూడా తగ్గుతుంది. ఆ హీట్ వల్లనే ఆ రెసిస్టెన్స్ పవర్ తగ్గుతుంది. ఆ తగ్గడం వల్ల కొన్ని ఎలక్ట్రాన్స్ అవుతాయి, నాట్ ఆల్. అందుకే రివర్స్ యాక్షన్ వెరీ లెస్. ఓకే, ఎస్ ఎస్. Okay, now coming to the reverse bias of the Zener diode, the difference between the PN junction diode and the Zener diode are the construction is same, but in that construction the doping levels are different. In the PN junction diode, the 1 or 2 atoms we are adding impurities to the pure 10 to the power 6 pure semiconductors. Now 1 or 2 atoms we are increasing for 10 to the power 6 pure atoms. So the doping amount is increased in the PN junction diode, and the construction is same as the construction of the PN Zener diode is same as PN junction diode. Okay, but here high impurity. In the normal PN junction diode, the normal impurity we are added, that impurity concentration is 1 or 2 atoms per 10 to the power 6 pure atoms. But here the impurity levels we are increasing depending on the manufacturing, depending on the usage of that Zener diode, we are increasing the impurity levels. So by increasing the impurity levels, that PN junction diode is called the GNR diode. Is called the GNR diode. Now the symbol of this GNR diode is same PN junction diode, right? But the difference is GNR diode. See, in the some textbook, the symbol is giving the Z is the forward direction and Z is the reverse direction. But better you can take the Z is the reverse direction. That indicates the PN junction, sorry, GNR diode works under reverse bias. That reverse of the GNR symbol, Z symbol shows that works in the GNR under reverse bias. Okay, the symbol of the GNR diode is okay. The forward, now you can apply the same. The GNR diode under forward bias and the GNR diode under reverse bias. The same. Right? Same. The forward bias of the PN junction diode and the GNR construction is same. Only you can, in place of PN junction diode symbol, simply you can place the GNR symbol. That is the forward bias and the GNR reverse bias. For character same as forward bias of the PN junction diode. The VI characteristics of the PN junction diode and the GNR diode both are same in forward bias. Here, the forward current and forward voltage. Same here. This is the for the germanium diode, 0.3 volt for the cut-in voltage. Right? Now, listen. Yes. Now, the forward bias of the GNR diode is same as the PN junction diode. How the PN junction diode is operate in the forward bias, the same way that can operate. Now, coming to the reverse bias of the PN junction, the PN junction diode will break. Okay. After certain voltage, the PN junction diode will not work because of the damage. After breakdown voltage, the PN junction diode will not work. So, after the PN junction breakdown voltage, the diode get damaged. Damage అయిన ఇంకేముంటుంది అక్కడ ఈ పెన్ ఉంది కింద పడేస్తే ఏమవుతుంది I can't write. Right? Similarly, if the diode is break, that will not work. But coming to the GNR diode, that will work. So now this voltage. So in the PN junction diode, that point is called breakdown voltage. Now in the GNR diode reverse characteristics, that voltage is called the GNR voltage. GNR voltage and what is the breakdown voltage? Up to certain reverse voltage of the PN junction diode under reverse bias, the diode will tolerate. అంటే కొంత వోల్టేజ్ వరకు డయోడ్ టాలరేట్ అవుతుంది. టాలరేట్ అయ్యి ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ ని కంట్రోల్ చేస్తుంది. బట్ ఆఫ్టర్ బియాండ్ దట్ పాయింట్ వాట్ విల్ హ్యాపెన్? Diode will damage. That voltage is called the breakdown voltage of the PN junction diode. Now the same way here, up to certain voltage, the diode, GNR diode is opposes this or that will stop the flow of electrons. Up to certain voltage. At what voltage? For example, here, up to this point, the diode is not allowing the flow of current, flow of electrons. Now, after this point, the diode is allowing the current, that is the electrons, but without damage. That voltage is called GNR voltage. After GNR voltage, if you are increasing the reverse bias voltage, the voltage across the diode is the constant. What is the difference here? After GNR voltage, if you are increasing the reverse voltage VR, if you are increasing the reverse voltage, the voltage across the GNR diode is the constant. That is called the regulator. Do you know the regulator? Regulators. Battery supply ఎంత కావాలి మీకు? మొబైల్ ఛార్జింగ్ బ్యాటరీ ఎంత కావాలి? 5 volts కావాలి. బట్ మన దాని నుంచి ఇచ్చేది ఎంత? 230 volts. ఆ 230 నుంచి వీఆర్ కన్వర్టింగ్ టు DC వోల్టేజ్. బట్ DC ఎగ్జాక్ట్ 5 రాదు. ఒకవేళ 5 కన్నా ఎక్కువ వస్తే ఏమవుతుంది? మీ మొబైల్ ఫోన్ విల్ బ్లాస్ట్. కొన్నిసార్లు బ్లాస్ట్ అవుతుంది. ఎందుకది? ఓవర్ హీట్ కావడం వల్ల, ఓవర్ ఛార్జింగ్ చేయడం వల్ల, లేకుంటే దానిలో ఉన్న రెగ్యులేటర్, ఇఫ్ రెగ్యులేటర్ ఇస్ ద డ్యామేజింగ్. అంటే రెగ్యులేటర్ అంటే ఏంటి? దట్ విల్ రెగ్యులేట్ ద అప్ టు సర్టెన్ వోల్టేజ్. మీకు 5 volts కావాలనుకోండి, ద రెగ్యులేటర్ విల్ గెట్ ద మోర్ వోల్టేజ్. ఎంత ఇన్పుట్ వోల్టేజ్ వచ్చినా కానీ దిస్ రెగ్యులేటర్ gives the only limited fixed voltage at the output. That is called regulator. Okay, ఇక్కడ ఒక 10 volts వచ్చింది అనుకోండి. Okay, 10 volts నుంచి మనకి ఎంత కావాలి? Only 5. So now we can use the one regulator here. Okay, that regulator it controls the voltage. Only that will give the only 5 volts as a output. So in that case, we are using the GNR as a voltage regulator. Okay, so this is we are using as a voltage regulator, and in the rectifiers also we are using this GNR diode. Okay, now so GNR diode. What is the difference between the GNR and the PN junction diode? What is the difference, ma? Yes, T-shirt. What is the difference between the PN junction diode and GNR diode? Yes. What is the difference? Tell me one application of the PN junction diode. Applications means where we are using that components. That is the application. So you can tell me the any one application. Yes, black shirt. When the diode, PN junction diode acts as a off switch. When that is acts as a off switch. ఏమేంటున్నామా మరి? నేను నెంబర్ ఆఫ్ టైమ్స్ రిపీట్ చేస్తున్నా సేమ్ టాపిక్ ని. Sit down. Sit down. Okay, so in the class, be attentive. వచ్చారంటే కూర్చుందంటే పోయిందంటే కాదు కదా. ఏదైనా కాన్సెప్ట్ తీసుకోవాలా, ఏదైనా నాలెడ్జ్ తీసుకొని వెళ్ళాలా. వచ్చినాం కూర్చున్నాం వెళ్ళిపోతున్నాం అంటే. ఓకే, సో ఫర్ ద నెక్స్ట్ క్లాస్ be alert. If you're having any doubt, you can ask me. Okay, now the lunch break. Now you can exactly you can assemble at 1:15 p.m. here. Okay.